So here we go. Page 9. Question 1. When you're in free fall, the only force that's acting is gravity. Very good. Okay. Number 2. Does the acceleration of a falling object depend on mass? No, it depends on the planet. Gentlemen, the acceleration depends on the planet. Here on Earth, we know that that is 9.81 meter per second squared. We saw the video of the feather and the hammer being dropped on the moon. We saw them falling together, so no, it does not depend on it. Number 3, what is the rate of acceleration due to gravity on Earth? It's 9.81 meter per second squared, and it is directed downward. Number 4, in what direction does gravity always cause objects to accelerate? Downward, yeah, down towards the center of the planet. Number 5, if the initial velocity of an object is upward in the positive direction, what is the sign of the acceleration due to gravity in a calculation? It's got to be opposite that, which would be negative. Number 6, when you throw a ball straight up in the air at the peak of its ascent, what is the ball doing? It stops and it changes the direction. In part B, what is the ball's velocity there? It is 0 meters per second. And the acceleration there is negative 9.81 meter per second squared. That should have been like a super easy page. It's taking you like two minutes tops to answer those questions. Let's go on to the next page. Number 7, if a ball is accelerated downward at 9.8 meter per second squared, by how many meters per second is the velocity changing every second? 9.8 meters per second. That's what the acceleration is telling you, the amount of velocity change every second. All right, page 11, guess method stuff. Number 1, how fast is the ball going after 3 seconds? It's traveling at 30 meters per second. In part B, how far it fell would have been 40 meters. Number 2A, the final velocity of the diver off the 5-meter platform would be negative 10 meters per second. Off the 10-meter platform, it would be negative 14 meters per second. In part B, the amount of time it takes the diver to fall off the 5-meter platform to the water is 1 second. To fall off the 10-meter platform is about 1.4 seconds. Number 3A, the amount of time it takes the rocket to get to the peak is 5.99 seconds. In part B, the total hang time is, with 3 sig figs, 12.0 seconds. In part C, what is the peak height of the rocket? It is 176 meters without the sign. So the height is just 176 meters. Number 4, in part A, which one hits the ground first? They don't. They hit at the same time. In part B, the watermelon will hit first because now you're throwing it downward. You're giving it an initial velocity, so its initial velocity is not 0. In part C, if the watermelon takes a second to get to the ground when you throw it downward, how tall are the stands? They would be 15 meters tall. And in part D, the pumpkin would take 1.7 seconds to fall that same distance. Now, before I give you the answers to the multiple choice, let me just talk to you about how these show work questions are graded in terms of point allocation. Same way I graded your Unit 3 test when you had a show work question. Here is generally the point breakdown. You always get a point for copying the correct equation off the reference table, picking the right one, copying it down. You get 1 point for correctly substituting in the proper values. 1 point for correctly doing the math, coming up with an answer. You get 1 point for putting a unit everywhere in the question. So every number that is a measurement has a unit after it every single time. You miss one unit, that point's gone. 1 point for an answer that has correct sig figs. 1 point for the correct direction on your answer if I asked you for something that was a vector. And if your equation has to be algebraically manipulated, you're going to get 1 point for that correct algebraic manipulation. So that would be a 1, 2, 3, 4, 5, 6, 7 point question. Showing the work. Okay, so just keep that in mind. By the way, you don't write down the correct equation off the reference table, you get nothing. You get nothing. You lose all 7 points or 6 points or 5 points, which is what happened to some of you on the last test. You started with an incorrect equation. You either copied it off the reference table incorrectly or you made up your own equation. You're not Albert Einstein yet. So don't be making up physics equations. Yep. It's coincidental. Correct. It has to be correct physics. So what I would be doing is checking if you have a correct equation from the reference table. If that would work based on the information given, then I can give you credit. However, let's say you start with a wrong equation. You use that d is VIT plus half AT squared, but you forget the square on the t at the end. You copy it down without that square. You just made up a physics equation. You get nothing. Okay? Because you have to start with correct physics. That's not correct physics. I can only give you partial credit if you start with the correct equation. Okay? So it's very, very, very important to look at that reference table and just make sure you're copying it down correctly first. Just copy it over correctly. That's true on the Regents exam as well. You start with the wrong equation, we can't give you any partial credit at all. At all. We're not allowed to. So we play by those rules all year. Okay. Any of those questions you want me to go over before I give you the answers to all the multiple choice? Jackson. Yes, let's look at 4C. Okay. So this one is about the watermelon. So in terms of your given, we told you that we were throwing it downwards at 10 meters per second. So that means the VI is 10 meters per second, but it has to be directed down, negative. The acceleration is from gravity, so negative 9.81 meter per second squared. And the time you were told is 1 second. So you're looking for D. So when we look at our reference table, page 6, the equation that has a VI, an A, a T, and a D is D is VIT plus half AT squared. There's no algebraic manipulation to do, so we can go directly to substituting in with units. Negative 10 meters per second times 1 second plus 1/2 of negative 9.81 meter per second squared times the 1 second squared. And when you do that, if you had doing it correctly on your calculator, you're going to get negative 15 meters. Now, this question says, how tall are the stands? That means I'm looking for height, a scalar. So we would drop that negative sign, and the answer would just be 15 meters. Anything else from the show work? Yes.
Question 11. You go over, on number 11.
Page 11?
Yeah, 1A.
1A. Okay. So we're telling you it's dropped, rest, how fast, 3 seconds. So that gives us our givens. The VI is 0 meters per second. Your A is negative 9.81 meter per second squared. The T is 3 seconds. You're looking for the VF. So the best equation with a VI, an A, a T, and a VF is the VF is VIT plus half AT squared. So that means we have VF is 0 meters per second plus negative 9.81 meter per second squared times 3 seconds, or you could just drop out the VI, either way. Gives you negative 30 meters per second. Now that's the velocity. I asked how fast, which means I'm looking for speed. So without the direction, it's 30 meters per second. 1 sig fig because of that time.
Yeah, I was confused about this thing.
Yeah, it's only 1. CJ? I'm sorry, 2A. Okay, so here we have 2 problems to do. One for a platform diver going off the 5-meter dive board. The other one's off the 10-meter dive board. Now, here's where the sig figs were a little confusing. This worksheet didn't put a decimal point after that 0. There should be, because I know this one to the nearest meter, so I should know that one to the nearest meter. That's why I'm putting a decimal point after the 10, okay? Otherwise, you're going to get the same answer for the 5-meter dive board and the 10-meter dive board, which makes no sense. The further you fall, the faster you're going to hit the ground. So let's start with our 5-meter diving platform. The VI is 0 meters per second. The A is negative 9.81 meter per second squared. The displacement is negative 5 meters. The diver goes down 5 meters. We're looking for the velocity when it hits the water, so that's the VF. So the best equation from your reference table is the one for VF squared, which equals VI squared plus 2AD. So to solve that for VF, we're going to take the square root of VI squared plus 2AD. Now we are going to look for the negative root, not the positive root, because you have to ask yourself when you take a square root, do you want the positive or the negative answer? The diver's going down when they hit the water. Many of us have seen on television the divers going off the dive board, and you can see them slowing down in the water after they've hit the water, but they go down a distance first. So they are traveling downward, which is the negative velocity direction. So that would be the negative square root of 2 times negative 9.81 meter per second squared times negative 5 meters, which would give us with the 1 sig fig, because of the 5, negative 10 meters per second. Now, if we do the same thing for the 10-meter platform, it's the same equation, but now I'm going to go to 2 sig figs with that negative 10 because I'm making it negative 10 point. So that answer becomes negative 14 meters per second. Make sense? Okay. Anything else? Yes, Joshua. I'm sorry. For D? Okay. All right. So did you get the height in part C? You got the 15 meters? Okay. Then you actually need me to go over C. I just did that. Okay. So now if you have this, those are your givens now for part D. The pumpkin is dropped. So the VI is now 0 meters per second. A is negative 9.81 meter per second squared. The displacement is negative 15 meters. So we're looking for time. So this is the VIT plus 1/2 AT squared equals D equation, but you got to solve it for T. And notice it is quadratic for T. So you have to simplify it first. There's no way to get around it. You're going to drop out the VIT, that's 0, and then solve it for T. That gives you the square root of 2D over A. That is the square root of 2 times negative 15 meters over negative 9.81 meter per second squared. I'm going to round my answer to 2 sig figs because of that displacement, which gives me 1.7 seconds. All right? Yeah. So if we have this, and we know this drops out, we're really working with just this equation. And if I want to solve it for T, the first thing I have to do is get rid of the half A. So I can divide both sides first by the half A, which means that T squared is D over 1/2 A, or remember, dividing by a fraction is the same as multiplying by the reciprocal, 2D over A. Now I have to get rid of that square root both sides, and that's the manipulation I gave you. Okay. Anyone else? Anything else on those show work questions? Bryce, we don't need a Chromebook. Okay, let's now go through the multiple choice. Here are the answers to the multiple choice questions. Starting on page, what is that, 13? 1 is A, 2 is C, 3 is C, 4 is D, 5 is C, 6 is D, 7 is D, 8 is B, 9 is C, 10 is B, 11 is A. Number 12 is C, 13 is B, 14 is C, 15 is C, 16 is A, 17 is B, 18 is D, 19 is C, 20 is B, 21 is B, 22 is D, 23 is B, 24 is B, 25 is C, 26 is B, 27 is C, 28 is B, 29 is D, 30 is C, 31 is B, 32 is C, 33 is B. And on the last page, 34 is B, 35 is B, and 36 is C. All right, any questions on the multiple choice that you want me to go over? Yes, Mohammed. Number 8. Okay. And this says, as an object falls freely near the surface of the earth, what happens to the velocity? Well, the velocity is going to get bigger and bigger and bigger. Speeds up as it falls.
Isn't it increasing in the negative direction?
Right, but it's still increasing. Decreasing means it approaches 0, which is not what happens. The number gets bigger when we're done reviewing. Anything else that you want to go over on the multiple choice? Yes, Jackson? I'm sorry? Number 4. Which graph represents the motion of a freely falling body near the Earth's surface? They're all speed graphs. All right, so Jackson, let's use my pencil as an example. In words, tell me what happens to the speed of this pencil as it falls. Was it speeding up, slowing down, traveling, or speeding up? You need a graph which shows it's speeding up. There are 2 graphs here which show it's speeding up. C and D. C is incorrect because the slope of it is getting bigger, which means that the acceleration would be increasing over time. This one, the slope is constant, so that means the acceleration is a constant value. And as things fall, we know the acceleration is the acceleration of the planet, constant value. So it's got to be D. Anything else that you want to ask about on the multiple choice? Remember, tomorrow's test, you're going to have 10 of these multiple choice showing up. Yeah. I'm sorry? 31, you got it. Okay, 31 says that we have an object which is allowed to fall freely near the surface of a planet, and the acceleration due to gravity on that planet is 24 meters per second squared. I want to know how far it falls during the first second. So if I were to list my givens for this, Josiah, I would say that the VI is 0 meters per second, the acceleration is negative 24 meters per second squared, and the time is 1 second. How far means I'm looking for the distance. The only equation on page 6 of your reference table that has these variables is D is VIT plus 1/2 AT squared. Since VI is 0, that will go away. So we're going to do D is 1/2 of negative 24 meter per second squared times 1 second squared. Half of 24 is 12. 1 squared is 1. So 12 times 1 is 12. So the displacement would be negative 12 meters, which means it's only going to fall 12 meters. Choice B.
Since it says falling freely, that's why the initial velocity.
Yeah. Anything else? Yeah. You got it. 29 says, starting from rest, object A falls freely for 2 seconds and B is falling for 4 seconds. Compared to object B, compared to object A, how far does object B fall? This was actually on your 4A quiz that you took. And what we have to do is understand mathematical relationships given by equations. We have an initial velocity, which is the same for both. We have the same acceleration for both, but one of them, the time is 2 seconds. The other one has a time of 4 seconds. And I want to know, how does that affect the distance you fall? So based on these variables, the equation which should guide my thinking is the D equals VIT plus 1/2 AT squared. And since VI is 0, we're going to forget about that. It's just this. The half and the A are the same for both objects. So forget about it. It's not really going to impact the relationship between the distance and the time. So what we see here is that distance is proportional to the time squared. There's a quadratic relationship, which means when I look at what's happening here, I am multiplying the time by a factor of 2, which means that when I plug in a multiplied factor of 2, 2 squared is 4. So I get 4 times the answer I originally had, which means it goes 4 times as far. Okay, does that make sense? If this were just D is proportional to T without the square, doubling the time, that would be a direct relationship. Time and distance would be directly related. They're not. This is a quadratic relationship, which means that if you double that variable, 2 squared, doubling 2 squared gives you 4. So you get 4 times the value. Another way to do it is just plug in the 2. So you could calculate it. It takes more time. So 1/2 of 10 times 2 squared versus 1/2 of 10 times 4 squared. Well, half of 10 is 5. 2 squared is 4. So 5 times 4 would be 20. Half of 10 is 5. 4 squared is 16. So 5 times 16 would give us 80. This is 4 times bigger than that. And remember, multiple choice, instead of using 9.81, make it 10. So the math becomes a lot easier. You can do it in your head quickly like I did. Okay, 4 times bigger. Anything else? All the rest of the multiple choice you felt comfortable with? You weren't like scratching your head, which one is it? And then you took a guess? Because you don't want to guess tomorrow on the test. You want to know how to get the right answer, not be guessing. Okay, so that means, what do we need to be working on? The only written assignment you have left for the marking period is your quarter exam review packet. And that quarter exam is on units 1, 2, and 3. We will go over that on Thursday this week. What's happening tomorrow in class, since tomorrow you have a double period? The first period, we are taking your test. And for tomorrow's test, you need a pen, a pencil, a ruler, and a calculator. The second period, actually, I shouldn't say the second period. Once you finish your test, you'll have the rest of the class period to work on makeup work if you owe me things, if your name is on my naughty list up front, or to work on your review packet to finish it up for Thursday. Okay, I'm not going to start anything new. At least I don't want to. If you are not on task during class, that's giving me a signal that I should start new material with you, Unit 5. I am ready to go. So if you don't want me to start Unit 5, then I expect you to be on task with your physics here. Okay? Questions? Okay. He has to go first. When he comes back, then you may go. All right.